Hey there, today we'll be doing this question that appeared in Codeforces round 835 div 4, which is E binary inversions. And the question statement given is you're given a binary array of length n. You are allowed to perform one operation on it at most once. In one operation, you can choose any element and flip it, turn 0 into 1 or vice versa. And they have told you to find the number of maximum inversions we can have if we perform one such flip. And what is inversion denoted as? It is denoted as take any two indexes such that I is less than j. The value of a of I should be greater than value of a of j. Now let's understand this better with an example and also how did we do it. So for this I've taken this example right here, and just to rephrase the inversion part once again, inversion means choose an I, choose an j such that the value of a of I is greater than a of j. So that is called an inversion. Fine. So I hope you have understood what does inversion mean for this question. Now, how do we go doing it? So for this question, we have to observe a little thing right here. Like for every indexes which have 1 in them. So right here we are having 1. Fine. So this guy will only pair up with all the zeros which are to the right of him. Okay, this is pretty evident because he cannot pair anything, any zero behind him, because we'll be violating the condition that a of I is greater, right? So a of I will be lesser in that case. So that will be a violation of this condition. So we cannot do such. So now, for every 0, we see that we can pair this guy with all the ones that are appearing to the left of him, right? So I hope you are getting some intuition like how do we do it. So obviously you will be needing a array which says that okay, for this element, if this is a 0, how many ones do I have to the left of this guy? Okay, for zeros I'll just write it here, and I'll also be dry running this approach so as to make it clear. For zeros we'll have to check how many ones do we have on the left, and for all the ones we need how many zeros do we have on the right. Okay, so this is what we'll be creating later on, but now let's understand this how will we do it first. So they have said you can do this operation at most once. Now where can we do it? So you might be thinking, why not just do it on the last index or the first index, something like that, but that will go wrong. You'll have to try out every possible index. Like if this is your index, you'll have to go on every index and try to flip it and try to check it. Okay, this is your answer that is getting that is coming out, and you'll have to take such from such answers the maximum ones. So for index 1, let's just say for this index, or rather we can just take on the next index, which will be a better example. So what is the total inversion right now without doing any change? You'll see for this one how many zeros do we have on the right of him. Okay, so we'll be having this array, we'll be calculating it later. And how do we do it? It is a very simple implementation. We can do that obviously later on, but just remember that we are having some array which is storing for every one how many zeros it has to the right of him, and for every zero it is storing how many ones does it have to the left of him. Fine. So we have two arrays for such. So when I'm standing at this index, I see okay, how many zeros do I have on the right of me? I'll get it from my array in O of one time, and we find that we have three. Okay, well and good. Now we find okay, there's this one once again. How many zeros do we have to the right? Now that's one. So how many we are getting? Number of inversions, it is coming up to be 4. Now also, whenever you're going to a index 0, now let's just tweak this input statement a little and we'll try to find it out. You'll see whenever we are at a index 0, we'll try to find how many ones do I have to the left of me, obviously, right? So we also see that this is actually taken care already. That means while we were onto this index, we actually had taken care of all the zeros part itself. So we do not do such operation twice. Fine. But now let's just say if we are coming onto this index and we are saying that okay, for this 0 I will make it a 1. Okay, I will make this 0 to be a 1. Now what do we have? So if we see previously, what was my answer? Previously I had gotten 4, right, with the initial array. When my array was something like this, I had gotten an answer as 4, right? But now I'm saying I'll change this input array to be something like this: 0 1 1 0 1 0. Now how do we recalculate the whole inversions in just O of 1? Because the time they have said has to be somewhere around O of n or O of n log n in order to get the answers to be passed, right? So how do we do that in O of 1? Now, coming on to this, we'll have to recalculate the whole inversion part again. Now, we are just concerned about this index, this part. I knew that previously my answer was 4, but after I have changed this 0 to 1, what is my answer now? So, whenever we had this 0, previously, what was it contributing to my answer? And right now, there is a 1. What will it contribute to my answer? So, if I have changed this to 1, what are we going to have? We are going to add some more inversions to my answer. Why so? Because see, there is a 1 here, and I know there are some elements which are 0 to the right of me, obviously. So I am sure of it that I will be adding some more inversions to my answer. Fine, so let's just add those inversions now. So the number of inversions that will be added is nothing but the current position, and just check in the zeros array that okay, how many zeros do I have to the right of me? For this index I have 2, so I know I'll be adding to my answer a plus 2. That is perfectly fine, but also we need to check that how many ones did we have to this. That means this was a 0 previously, right? This was a 0 previously. Since I changed it to 1, what happened? This 0 became 1. Now if I know there were some ones previously to me, they had taken this 0 as one of their pairs. I'll just rephrase this statement again. See, previously I had my array as this, right? Now, this was never changed. So this one, what did it do? It took a pairing with this guy, right? But now, since I have changed this to a 1, right? Since I changed this to a 1, what do I know? I know that any guy or any ones which are appearing previously to me had a pairing with me, but now since I am changed, he or she, he I mean it cannot take a pairing with me. That's the thing. And why am I referring this one to be he and she? I don't know why was I even telling it. But anyways, coming back to the question, so this guy right here was pairing with all the ones previously to it, but since it's changed now, what do? We subtract all the number of ones which were previously there. So this one was previously occurring. So I can just check in my zeros left array that okay, how many ones do I have to the left of me for this position right here? And I see okay, there's only one which was previously pairing with me, but now it cannot, since the position of this guy had changed its bit, or it just flipped it. So the number of ones which were previously occurring was 1. So right now my answer stands out to be 4 plus 2 6 minus 1 5. So this is what your answer stands out to be. Fine. And if you just check it again, you'll see that yes, it is indeed 5. So this one will pair with these twos, and this one will again pair with these twos, and this one will again pair with 1. So see, it comes out to be 5, right? So I hope you have understood the basics of this, that all you have to do is maintain two arrays, that is a zeros left array and a ones right array, which will say, okay, for every zero, the number of ones to the left of me is this much. And for every one, the number of zeros to the right of me is this much. Okay. So this is what we'll be doing. And after that, what did we do here? We checked for every zero and we flipped it to 1, right? Now let's do another kind of operation, that is flipping a 1 to 0. and find out how do we do it. And after this is done, I think you'll be able to implement it also, and write the code and get it easy also. Okay, and also the code link will be in the description. You can check it out from there as well. Now let's just do this operation one more time and we'll be done for. So after changing this 1 to 0, what do we have? We see that okay, this guy, that is this one, it was 1 here, right? But now, since I have changed it to 0, I know this 1 was contributing something to my answer. I know for a fact that that it was contributing. And how do I make sure of it? I'll just calculate the answer for it. That means for this index, how much was this guy contributing to my answer? And how do we do that? You must have guessed it. Yes, obviously, we'll just check that in the once right array. That means for this index, how many zeros do we have to the right of me? And the answer to it is 3. So this index, before I flipped it from 1 to 0, it was giving, or it was contributing to my answer 3. But now since I have changed it to 0, now anything, it will just be subtracted from there. And why so? Because obviously, right, now I'll be concerned about the contribution of this 0, not this one. This one was contributing to me, to the answer previously when it was 1, but now since that it has been changed to 0, now this I will be recalculating my answer for this 0. Now let's see how many coins or whatever is this 0 contributing to my answer right now. So for 0, what do? We check all the previous ones, or all the ones that are occurring previously to this index. And we can do it how? We can just go in the 0 left array and we'll check, okay, for this index, how many ones do I have previously to this? And we'll see that the answer turns out to be 0, obviously, because there are no ones there. And if the answer turns out to be 0, that means how much will this contribute to my answer? If I change or flip it to 0, it will be contributing 0. So how do we recalculate it? So if I just erase this once again and recalling the first thing, that means if I just erase everything up and I say that okay, this is your original array, what was our answer coming out to be? If you remember, it was 4. Okay, the original array, I'm talking about the original array when we had not done this 1 0 operation. So the answer had turned out to be 4. But since we have done this operation, that is changing 1 to a 0, now we know that this guy is contributing nothing to my answer. And also this 1 was previously contributing 3 to my answer. So this 1 is no more there, but a 0 is there. So I'll be subtracting whatever 1 contributed to my answer, that is minus 3, and we'll add plus 0, which doesn't make any sense, but still we'll be doing it for the simplicity case. And the answer turns out to be 1. So the whole array, now if I change this index, if I change this, if I apply the at most once condition of flipping to this index, I'll be getting the answer as 1, which is obviously worse than what we had gotten since the no changing part, right? So we'll be continuing further and we'll be trying for every index. So I hope the whole intuition behind this problem and how to do it is clear now. Now we'll be just checking the code part and you'll be good to go with it. Fine. And also for this, I have some more arrays which have been declared and which have not been used. So you do not need to take care about that. All you need to check is the part where I had written that we'll be considering only the 0 left part and once right part. Okay, we are just concerned about that. So once left, we are just concerned about this once left, and uh, where is it, once left and once right. Okay, this is what I've mentioned here. Fine, once left and once right. So these are the part. So it might get confusing a little, but while implementing it, why did I write it, I still don't know, but I just wrote it for some reason and never used it. But these are the only things that you need, that is once left and once right. Fine. And after that, what are we doing? We are just coming on to here. We are just incrementing all the values whenever we are getting. That means how do we do that? Let's just come here. Okay, sorry, I mentioned once left and once right, but it is zeros left and once right. So just check this part a little and we'll be getting through it. And how do we calculate this array? We'll be coming on to this part again. So for zeros left. How do we do it? We know that all we care about is all the left ones, right? So we'll come at the first index. We'll see, okay, here we have a 0. Let's just move ahead. Here, the number of ones to the left of it is how much? 0. Here, what is it? 1, 1, again a 0, again a 2. And how do we implement it? So let's just see it here. So this ones left part is indicated here. And by the way, this 0 left is of no use. Okay, again, I'll be telling it. And while I'm putting the code link, I'll just remove the unused part also. So, okay, so don't worry about that. I'll be removing this 0 left and the part where I have written 1 right, this part. Okay, so I'll be removing these unused part also, so you don't have to worry about all of these things. So coming on to the part where we check for ones left, what am I doing? I'm just checking if the value is a of I is 1, I will be incrementing a value. I'm just taking a simple value which is a counter which is tracking all the ones that we have, and we are just storing it in our array. Fine. And after this, what are we doing? We are calculating the initial score. And what is this initial score saying? See, whenever we had the input array, we had calculating the score, right? What it was at the first only. So without changing anything, we had some score. What if that is only the maximum, right? We do not need to do any changes. So that is why I've just made sure that I've just calculated the initial score. And after that, what are we doing? We are just going on to this part. And what is this part doing? If the value of my current index is 1, what am I doing? I can change it to 0. And what do we do for 0? Always remember that for 0, what are we doing? Whenever we change a 1 to 0, what do? We just say that, okay, now this guy is 0, so I need all the ones to the left of me. All the ones to the left of me, we just need that. And whenever we have done that, we will just subtract the answer which this one was contributing previously to my answer. Fine. So we are just doing that part here, and at every step we are just considering the maximum score at each and every point. And when we are done with it, we just return the maximum answer that we have gotten so far. Okay, so this is the whole explanation. I'll be telling you. So, and after this, I'll also be linking the description code. Fine, please do just dry run this once. I'll be removing the unused part also, so no need to worry about that. And please do just dry run this once, you'll understand it properly. Okay, and if you still have any doubt, you can ask me in the comments. And if you did like this video, please do like and subscribe. And yeah, thank you for watching. And yeah, that's it for today.